Welcome to the photo booth world, a collaborative infinite gallery where you can discover pictures made by other users and post a photo of your avatar by choosing a background, pose, and accessories to contribute to this ever-growing collection. Hi, in this video I will guide you step by step to create this project with Three.js and React. And I'm excited to share that we'll be deploying it using VIVERSE, who is sponsoring this tutorial. VIVERSE is a platform designed for developers and creators to publish and share interactive 3D web experiences, and it's completely free to use. What makes it perfect for our photo booth project is that VIVERSE has sponsored the development of the pmndrs VIVERSE library, which provides an SDK for both vanilla Three.js and React 3 Fiber, which gives us instant access to features like authentication, customizable avatars, physics, and leaderboards right out of the box. Plus, with their CLI tool, deploying your project and getting discovered on their platform takes just a few comments. Publishing to VIVERSE is fast, with no gatekeeping, and you stay in complete control of your work. So let's dive in and build this collaborative photo booth together. To get started, let's use my React 3 Fiber starter pack, link in the description, copy it, in a terminal, clone it. I will save it into Wawa photo booth world. Once cloned, file, open folder, open it, we install the dependencies and start the development server. Let's follow the link and we have our React 3 Fiber project up and running. Now let's use the VIVERSE SDK to be able to quickly prototype our game, our experience. Our project already have 3 and React 3 Fiber. Let's take 3 VIVERSE. Add it to our project. And for now, let's copy their simple example. We will wrap everything inside a VIVERSE component. Inside our app component, we can wrap everything inside. And to understand the different components they are using, we can go inside tutorials and building a simple game. It's a very nice tutorial to get started using the SDK. Let's add the sky and lights inside our main experience component, paste it, and we can remove orbit controls as it will be handled by the SDK component. To build our level, we will use the physics component they provide, which are here. It's a physics body that will automatically add colliders between our character and the different meshes inside. Prototype box, we will see what it is. Let's add it to our scene and do the imports. And last but not least, let's add our character with the simple character provided by the SDK. All right, let's add it here, import it from VIVERSE. Let's try it, and you can see that the camera is perfectly following our character. We can move, we can jump. Our character is animated. It's a very simple solution to create a game very quickly. You can go further and add a respawn logic, but it's not a need that we have for our experience. There's a lot of features you can find in the documentation. For example, adding items to the different bones, choose between different avatars and animations. All of these can be found in the documentation, but we will see it together as our game development progress. Before adding features to the game, I want to have the full pipeline ready. What I want to achieve is to publish our experience into VIVERSE. First, you need a VIVERSE account, follow the link, and to install the CLI. Then by running this command, you can log into your account, install the CLI. If ever you have an issue, maybe it's the Node version you're using. I will use the 23rd and try again. And now it works perfectly. Now log in to our account, paste here, put your credentials and enter, and I'm perfectly logged in. Now let's create our app. I will name it Wawa Photo Booth World, enter. You can add a description and it will give you an app ID. Copy it. We want to include it inside our build in production, but not in development. To do so, we create a new environment file that we name .env.production. We paste our app ID, we get the key with VIVERSE app ID, and we save. Now we simply attach it to our VIVERSE wrapper Here it is, and by doing this, it will be only set in production, in the production build. We can now build our project, yarn build. The build folder is usually dist, and we have this command to publish our app. Let's paste it and replace the different things. Our build output directory, dist, and our app ID, here. I recommend you to copy this command somewhere for smooth updates of your project. Let's run it, and it should be available on studio.vivers.com. Okay, we can see both of my projects, the one I prepared the tutorial for and the new one. Let's preview it. We have the Vivers loader, and our game is now ready, and it's using my Vivers avatar directly out of the box. A good transition to start building an avatar picker, because with Vivers, every user has avatars. You can go on the top right and go to avatar. You can create a new one or view your avatars. And you can see I have 3 of them in different styles. This one, this lady, which is the best of my avatars, and this one that should represent me. It's quite accurate, but I was still wearing my glasses, so it gives this a nice headband. Feel free to create your avatar by choosing one of the different styles or importing a VRM. To get access to our current avatars, you have all components and a hooks page in the documentation. The hook that interests us is use Vivers avatar lists. Here it is. Let's create a simple UI component. New file UI. Let's create the component for it. We will return for now a fixed div. Put it on the bottom left. To organize our project, let's have a subfolder for the UI components, and we will create avatar picker. Okay, let's create the component. For now, it will return nothing. We just want to call use Vivers avatar list into avatar lists and log it. Let's stop the Russian doll. In UI, we import avatar picker. And in our app, we need to use our UI component. If we go back to our experience in the local development server, the list is undefined because locally we can't authenticate our account to Vivers. Let's rebuild, publish our project, reload our project. I noticed sometimes you need to clear the cache to be sure you have the latest version, so you can do it. Okay, now we can see in the log we have the avatar list, which is an array containing the ID of the avatar, the URL, and a snapshot, the profile picture of our avatar. With this array, we will be able to display them and to choose between different ones. We will use Zustand for a unified store within our app. Let's install it. Zustand, we create a hooks folder, and I will name our store useworld.js. We create our store, import from Zustand, and inside we will want an avatar and to be able to set the avatar from our UI. Now in avatar picker, we can return avatar list.map. And for each, we will display a button with an image representing our avatar. On click, we will set the avatar with the avatar data. Let's get our avatar from the store. I forgot to export it and set avatar. Import it. But remember, locally, we don't have the avatar list. Let's have some fallback data. Create a file, sample data.js. We will do a simple check to see if we are in development, if we don't have an app ID. And if we are in development, I will list all my avatars. Otherwise, I will just fall back on my default avatar. So when users are not logged in, they will at least have my avatar and not the yellow default model. Now inside the avatar picker, we can use Vivers avatar list, or if there is nothing, we fall back to our data. Okay, now we can see the pictures on the bottom left. We will polish the UI later, but we are able to click on them and it should set the avatar. Let's see how to change the avatar with custom models and animations, and to be able to use a different avatar than the default one or the one attached to our account, we can use the model on top of it. Let's go to our simple character here, add model equal, based on our avatar, we use it or we don't set it and it will fall back to the default. Let's access our avatar from our store. Now at the beginning we have the yellow one, but if we click on an avatar, you can see it changed to another one. To avoid the full refresh, wrap it inside a suspense component, which will result in only the avatar not being displayed and not the whole experience while it's loading it. If we don't want the yellow default avatar at all, we can use sample avatar list of 0 as the default avatar. Now when we reload, even for non-logged user or in development, people will have my avatar. To finish the VIVERSE authentication flow, let's add a login button for non-logged user. To get access to the user profile, to know if it's logged in and to have access to its thumbnail, you can use VIVERSE profile. For now, let's use it in the UI. And log it. Again, as we are in development, it is undefined. Build again and publish it. All right, we have user profile, my name, active avatar. Perfect. What we can do is again a fallback if we have nothing, to set its name to anonymous. And if our user is anonymous, we display a login button. The login function is use VIVERSE login. Let's bind it to our button. Of course, locally it won't work. We can build and publish it. Here it is. Here we are logged in, so no button. Because the project is private, we need to go to manage content, create a guest preview link, open it in an incognito tab. You can see we have the fallback on the default avatar. We have sign in on VIVERSE itself, and we have our login button. Now when we press it, we have the authentication flow starting. We can log in and we will be logged in on our experience. Now let's focus on our world and what we want to achieve. We have a room with 4 different directions, and we can go to other rooms and post photos. The world is infinite. To do so, we will need to create a grid. First, we are in the main room, this one, the center one. We are able to go in all directions, and same for each room. What we will do is we have all the doors. And as soon as we go to another cell, we will move our whole grid to follow our character. This way, we don't instantiate tons of rooms, and we give the user the impression that it is in an infinite world. First of all, let's simplify our prototype with only one platform, the main floor. We have our character on the central cell. Let's render the grid around us. In our state, we will need the following: the character position, the current grid position, and the size of the grid. You can use a bigger grid if you want to see very far ahead, at the cost of performance. Based on that, we will compute our current character cell. We use the position passed as parameter to calculate the X and Z cells we are currently in, and we check with our current grid position. If it's a new one, we will set a new value. This way, it will trigger a re-render only if we reached a new cell based on our position. And we can copy the position passed as parameter to our character position. This will be useful for later, so trust me on this. With this function, we want to call it every frame to detect if we reached a new cell or not. We have compute character cell from our store. In a use frame, we want to call it, and we need the position of our character. We use a reference for that, attach it to our character, and only if we have one, we call the function with the current position of our character. Now if we try, we have crashes because we need to define the size of our cells. This is for visual representation of it. Let's try it. If I jump to the void, it detected a new cell, but the problem is we don't have the grid, so I fall into the void. Now let's take care of rendering our grid. In a component, we can call it infinite world.jsx. We create our group. We will need our grid position and our grid size. As you remember, the grid will follow our character. We use the grid size to center it on the X and Z axis, and we put it slightly down. We need to import the grid cell size and half grid cell size, a shortcut to divide it by 2. And now we can loop through our grid size on the X and Y axis. As it's a two-dimensional grid, we use only X and Y, no Z. For each, we calculate its X and Y position based on the size of it and our position on the grid. Then inside we will render groups that we will position on the X and Z axis. And for each, we will use what we used previously, a BVH physics body with a prototype box. In experience, let's remove it and use our infinite world. We can see it, but the grid size is wrong. This is the one for the final model. Now it should be 10 as we are using 5x5 boxes. Okay, we can see it. If we navigate, it is moving, but the collider didn't work. This is because what we are doing here is moving the whole group, the whole container of our world. And if you move the physics body, you need to set it to kinematic, so it's updated when it moves. Let's try it again. And now we can walk without falling in the void infinitely. Again, expand the grid size if you want to see a lot far ahead. But the trick I use in the final project is to use a fog so we don't see further ahead. This way, we don't have to use a very big grid. To be able to understand where we are on the grid, we can use a text displaying the current room on the floor. Okay, they are above the floor. I guess the issue is here. As our box is 0.5, let's take halfway bottom, much better. And now if we navigate, you can see the room number updating on the x-axis -2, -3. And if we go behind on the z-axis in 3D, but y-axis in 2D, we can see it's growing perfectly. All right, now we have our grid ready. What we will want to do before adding the real room, the colliders, is how to generate the pictures. First of all, we need somewhere to store the different pictures we take in which room and by who. To do this, we will use Pocketbase. It's something that I used in a previous tutorial in the avatar configurator, so I will put you a link if you want to learn how to set up a Pocketbase instance. Otherwise, follow the documentation. So for this tutorial, I will assume you have a Pocketbase instance up and ready. I will create a collection that we will name photos, and inside photo, both world photos. Okay, by default, it generates a unique ID, a created and updated date. Let's add our fields to it. What we need to know is in which cell the image is attached to. We store it in a number, cell X, and another one for cell Y. So we can request it easily based on the X or Y axis. Then, because in each room we will have multiple pictures, we will attach them to a frame. It's like a unique identifier for each frame. Let's name it frame. And each room will have the frame 1, frame 2, until frame 8. Then the most important, the picture it generated, the photo. For this, we can use a file. Let's name it photo. And we can store additional data. Even if you won't necessarily use it, it's good to store as much as you can. Username, a link to the profile picture, head icon URL, it's the naming on VIVERSE, and that should be good. Let's hit create. It will create my new table. For now, we can create a new record. Let's say at 0, 0 for frame 0, 1. I will upload manually my picture, open, my username, and my head icon URL. Let's create it. And before uploading our pictures, let's see how we get the pictures from our collection. To do this, we go to API preview. You have a list, view, create. What we want to do is get all the images, so we use the list. And what we want is to get all the data. So we will take this here. To be able to use it, we need to add Pocketbase to our project. All this logic will be in our global store. We can copy paste the import and the line to connect to my instance. We want to get all the pictures, which is this line, get full list. Let's create a function here that we will call load photos. It will be async. And let's try it. We won't use the sort. We can console log what it gets. And to call it at the very beginning, we can do useWord.getState.loadPhotos. So it's done at the very beginning of our project. It's trying to do it, but we have an unauthorized error. We need to set up the rules on our collection. Go to Edit Collection, API rules. Currently, only the super users are able to do it. We can unlock it, leave empty so everyone has access to it. Perfect, it's public. Save changes. Confirm, we reload, and in records, there is an array containing our picture. Now we have access to our photos. We want to upload a photo based on our camera. To take a screenshot, we create in our store a function to save the screenshot and to upload it to Pocketbase. It takes the user data inside profile. To be able to do it, we need to get access to GL, the WebGL renderer. So we'll assign it later. Then we create a canvas. To generate square pictures, we take the shortest side to determine the size of our square. We create offsets to center it in the middle of our screen. We size our screenshot canvas, and we draw the content of our renderer into the canvas. Then to convert what is inside our canvas into an image, we call toBlob. If it doesn't work, there is an error. Otherwise, we will be able to send the data to Pocketbase. Before doing it, for now, we will just log it. We will need GL and a setGL function. Let's set it in our experience because we need to be inside the canvas in the React 3 Fiber context. Const GL, this is the one from 3. So we have access to the one in our used 3 context. We have a setGL to set it to our local store, and in a use effect, when GL change, we call setGL. So we also have it in our use world. Very important when you want to generate image from what is in the renderer. In the canvas declaration, you need to add this setup in the renderer. Preserve drawing buffer to true. Otherwise, you won't be able to get access to what is rendered to take a screenshot. Let's create a button to generate the screenshot for now. Let's name it take screenshot. On click, we need to prepare the handler from our world, and take picture will be equal to a use callback based on the current user. We can call save screenshot and upload with our user, and we bind it to our button. Let's try take screenshot, and we have a blob. Now we need to upload it. Better if I'm not in front of it. Now we need to upload it to the server. To upload data with Pocketbase, again, we will need to edit the API rules to allow anyone to create things into the table. Okay, and in API preview, we want to create data into it. We can take the example here. We can paste it here. But currently, there is nothing to send the actual blob, the file, into our collection in Pocketbase. Let's head to Pocketbase documentation, uploading files. So we need a file format, which is already what we had. And there is an example on how to achieve it, either using files, but us, we are generating the file, so it's easier to use a form data syntax. For the file name, we will use a date and avatar.png. Then we create our file using the blob. We create our form data to pass all the necessary data. We get it from our store. We already have the cell X, cell Y, the frame. This one, we don't have it yet, so we will add it, the username, head icon URL, and we add the file. Now we can send it to Pocketbase and we log if it's working or not. Currently, we don't have hovered frame, which is when we will reach a specific frame. Let's add it to the store. For now, let's set a fixed string and save. All right, let's see if it works. We can move our camera, take screenshot. We have the message photo uploaded successfully behind me. If I reload the collection, we can see that we have our picture, cell X00, the frame hard-coded. We have our picture and anonymous because I'm working locally in dev.env. Perfect. One last thing we can do is to be notified when a new picture is uploaded. Either it is ours or another user using at the same time our experience, even if it's not multiplayer. You could see pictures from other players that play at the same time appear randomly in your gallery. Go to API preview and we can use the real time. After we load the photos, what we simply do is we subscribe to all events on our world photos collection. When it happens, we call load photos again, which will reload all the pictures. This way, it is always synchronized. Before visualizing the pictures on the walls, we need to load the final room. Inside public, create a models folder and drag and drop the room file that is provided in the final repository. Link in the description. Here is what you will get. To load it, we will create a room component. Let's name it room.jsx. It will take the X, Y, and rest of the props for positioning. We put inside a group our room model by using GLTF component. And inside our infinite world, instead of using the prototype box, we will use our room. We simply need to pass the room X and the room Y. Thanks to the SDK, it's working out of the box for the collision, but the sizing is wrong. Let's update it to the real size of the room. This value should work well. Here we are. You can see the frames are empty on the walls. We can walk, change room. For now, when we go to another room, we can see it appear. That's why we can use a fog to fake the effect. Let's change the background color and a fog with the same color as the background color. Okay, it's working for the fog, but there is an issue with the background. This is because of the sky we used from the example at the very beginning. Okay, much better. It feels seamless while we know under the hood there is no room after this one. But because it will appear seamlessly, it's looking great. Now, what we want to do is to display the frame pictures on the wall. For this, in Blender, I separated the frames in a separate GLB file. You can take it and they all have a unique name, frame 01, frame 02. Let's use GLTF JSX with our file to be able to render our model declaratively. You can see all the different names. Picture 02, 01, 03, perfect for identifying them. Let's take this. Let's load it inside our room with the use GLTF. We can preload the file, so it's loaded at the very beginning. By the way, we can do it too for the room. We need to write the full path. And let's get all the different meshes, put them after our room. So it's in the same component for each room we want it. Now you can see it on the walls. We have different frames and materials. We can get rid of the cast and receive shadow. It's no use. And instead of displaying the material coming from the GLB, we want to create a new material by using as a texture the images from our database. Let's create it in this component, photo material. It will take the URL of the picture we want to display. Some frames don't have the pictures, so either we display the URL or a fallback image. You can find it in the final repository. Let's create it, images. We will have empty when someone can take a picture to it, and loading the time it's loading the image from the URL. We simply return a mesh standard material with the texture displayed on it. Now we need to create the materials and to pass the URL of the picture for each frame. First, what we need to do is to get access to our photos. On top of load photos, let's declare our photos. And instead of just logging it, what we will do is create ordered photos. And the goal is to be able to easily select a picture based on the cell X, cell Y, and the frame. We iterate through our array of photo and generate the key. And then we create a photo URL. We use the function from Pocketbase to generate the remote URL to the access of our picture. We assign the picture to our ordered photos and we set it inside our store. Now what you can see is that in the cell 00, we have two pictures, one for the frame 01. Now in a use memo, when the X, Y, and all the photos change, we will compute it. We get the key of the current room and we get access to the photos of it. Then in a URL object, we want the photo for each frame. So for each of them, we will assign the photo to the corresponding frame. This way, instead of using the default material here, in our mesh, we can declaratively use photo material and use the proper URL. We repeat the process for all the images. So now it is loading the picture. And we can see this one here. But you could see we had a blank screen while it was loading. This is not what we want. Instead, we can use a suspense component and display another material while it's loading. For that, we can use the fallback component. We create a photo material loading using the loading image and doing the same than photo material that we use in this case. I will skip you the best part to replicate it for each frame. Okay, I finished it. Let's do a quick test. Even if I have no idea which frame is the 02, we can use it. To avoid too big image, we can also use a max size of 124. Let's do a quick test to see if it works. Take screenshots. It's loading here. And here we are, perfect. Now what we will want to achieve is when we go near a photo frame to be able to open the photo booth, to be able to choose for item and different pose to take the best picture ever. Again, you will find it in the final repository, but I prepared a separate GLB for the room colliders. You can see it's nice cylinders. Let's use GLTF JSX on it, on the colliders. Let's take the whole component. We will save it in a new component. Frame colliders. Paste it. Do the necessary adjustments. And let's add it to our infinite world. Because what we want is to not impact the real collision. We want it to be sensors. So we can't put it inside here, and we only want to display them when we are in the same room. Before here, we can do a condition. If we are in this specific room, only there, we will use our frame colliders. Okay, now we have the frame colliders, but if we look to the other room, they are not here. If we navigate, they appear and they are not in the other one. Now inside frame colliders, we won't render the meshes as is. What we really want is the geometry and the position. We will create a subcomponent, frame collider. By the way, I made a typo on the file name. I'll quickly fix it. It will take the geometry, the position, and the frame ID. For it, we will return a group that will use the position of it, a mesh with the geometry we have, and for now, a mesh standard material that is transparent. We do this separation to be able to add a BVH physics to it, but a sensor. And the goal of the sensor is to detect when we enter in collision with it without impacting the physics. It won't block our character. Because our frame collider move like all the rooms, we need to set is static to false. And when our character interact with it, we can use unintersected change. Let's get access to the hovered frame and the set hover frame from useWorld. And for the callback function, when the collision change, what we do is if it is intersected, we set hover frame to the current frame ID of this collider. Otherwise, we set it to null. We are no more on any collider. For now, to be able to see it, we can set the opacity either to 0.2 or 0.5 if we are on hovered frame that is equal to frame ID. Maybe the opposite, by the way. Okay, this component should be ready. And now simply instead of using the mesh, we use frame collider. If you want to clean it up by removing cast shadow material, it's up to you, but it's not used by the component. Let's replace all of them. Now we can see we have our transparent materials. If we go on one of them, it crashed and it didn't like the set hovered frame. Let's go to useWorld, hovered frame. And yes, we need to code a set hovered framed. And now we can set the default hover frame to null. Okay, let's try it. And they are all highlighted. I think it is undefined for now. What we need here is on each frame collider. Okay, I can clean it a bit. Frame ID. I can see the name here is 01. So I can use 01. Perfect. Now let's try only the highlighted one changes color. For a better aesthetic, I prepared a custom shader material. Using shader material, I won't cover it in this video how to achieve it, but if you are new to shaders or to React 3 Fiber in general, you can check my course, link in the description. There is a dedicated chapter to shaders or even VFX, WebGPU and TSL. We can replace our mesh standard material with this custom material, which gives us a much better aesthetics when we reach the frame. Now let's enter the final stage. What we will want to achieve is when we are in front of a frame, we can press a key or a button to enter in photo booth mode. In this mode, we will be able to attach accessories or display another pose and also change the background of the scene. To be able to switch between being in the explore mode or the photo booth mode, we'll have a mode by default, which will be explore, and set mode to switch. In the UI, we can get access to hovered frame and set mode, and also access to the mode. If we are in explore mode and hovering a frame, we can add the button to enter into photo mode or exit photo mode if we are inside it. It should appear when we reach it. Perfect. Enter photo mode. Now inside our experience, we will render the simple character and infinite world only if we are in explore mode. So mode is equal to explore. Then we display this simple character. For infinite world, we won't reinstantiate, recreate everything. Instead, we will pass it as visible only if we are in explore mode. And remember, in infinite world, we pass the props, so it will be invisible for this group. We will do the same for a photo booth component that we will create and visible only if we are in photo mode. Be sure to import the current mode. We can create our photo booth component. We simply return a group for now, and let's check if we can switch between the two. I reach it, enter photo mode. We can see nothing because we are not displaying the avatar. Exit, but it's teleporting me back to the center. Remember, we have a character position inside our store that we can use here, and it will be used only at the instantiation, and it's a vector that is following our character position. Let's try it again. I can even change the room I'm in. Enter photo mode, exit, and I'm spawned exactly where I left. We want our character in the photo booth to take a picture of it, but instead of moving it from a position to the center, we simply recreate it and we'll attach a different pose to it. So here in suspense, we can add again the simple character. We disable physics. We don't want our character to fall. We don't want it to impact the camera. Instead, we will add a custom camera controls. We assign the avatar like we were doing before, and we also disable movement. It can't walk, it can't run, it's just there. We get access to the avatar from useWorld, and we instantiate it only if it is visible. Because we disable the camera, we can add our custom camera controls. We need a reference to it that will allow us to animate the camera based on if it is visible or not. Let's try it. We can move somewhere, enter photo mode, and we have the camera animation. Because we are using camera control, we have full power over where we can move to be able to take the perfect screenshots. We can handle in our store to go back to explore mode once we have taken the picture. But here you can see it. As it's a square picture, I should add some overlay to hide where the picture won't be taken. It would avoid this kind of pictures. Now we have our photo booth system. We can start having fun with it by adding custom poses instead of the idle animation by default. Mixamo animations are compatible. So you can go to mixamo.com, choose the one you want, download it, and store it and keep the FBX file. I have prepared you custom poses for our project in an animations folder. You can simply drag and drop them and use them freely. I also have prepared thumbnails in the images folder so you can see what they look like. In useWorld, let's add a pose and set pose using the first pose as default. And we have this array with the name, the thumbnail, and the animation file. Me, I'm using GLB file. All right, let's go to photo booth. And on our simple character, we will change its animation. So as we don't move, we are in idle. So we can override the idle animation. For advanced explanation about it, you can refer to the documentation, but let me show you the path with our GLB animation. We assign an object with the type that is GLTF. If you don't know the Mixamo one, set it to Mixamo. Then the URL will be pose.url. And to know the bone map it needs to use, you assign bone map. You have this constant provided by default by VIVERSE, Mixamo bone map. Okay, we need to get access to the current pose from our store. Const pose is equal to useWorld. Let's try it. Let's go to it, enter photo mode, and we are in Kung Fu pose. In the UI component, we can get access to all the poses and list them. If we are in the photo booth mode, we can do poses.map, and for each of them, we will call set pose with the current pose. We need access to set pose from useWorld. Now, if I change, you can see the dance pose, muscular pose, sitting one, standing Superman, my favorite. So you center it, you take a screenshot, a picture, and you have your amazing picture generated. To make our picture even funnier, we can attach accessories to our avatar. You can search, for example, hat, find one that you like, for example, the pirate one, add all the ones that you want in the model folder. I have downloaded both the GLB file and the thumbnail from Polypizza, and we can dive into the documentation to attach items to specific bones. Here you can see it has a sword, and the code is very straightforward. You declare a character model bone, you say to which one it is attached to, and you put your GLB, your custom meshes, inside it. Inside our simple character, we add a character model bone, and inside a GLTF containing our model. So for now, we assign it to the head bone. To get access to the list of the bones, you can refer to 3vrm and use the right part. Here we are using head, but you have the list of all the bones. This is what we get. It's on top of the head, but the scale is completely off. What we need to do is to find the proper scale. Better, but not perfect. The position, let's see what we get. A bit better. We still need to adjust the scale. 0.5. Okay, seems good. And we can also rotate it. Rotation. Find the perfect value. And let's say it is the perfect one. This is to be able to place them by hand. Then in use world, I created an items array containing its name, the thumbnail, the model, and to which bone it's attached to. So head for this one, the heart is the right eye, and also the scale, position, and rotation that you can fine-tune manually and then copy-paste here. Let's add item and current item. So by default, we say we don't have an item, and then we can set the item. Now, instead of typing this manually, we get access to our item. And here we only add one if we are using an item. The bone is item.bone. This you can just comment it. So when you want to fine tune it, you can do it later. Source item.url. By the way, it is model. And pass the scale, position, rotation from the actual item. Let's add them in our UI. We won't do the good looking UI together, but it's just so you have the logic and can make the UI of your dream later. We need to have a set item, and exactly like we did for the poses, we will do items.map, and for each of them a button to set it. Okay, now if we take chicken, we have a chicken on top of our head. We could also combine them. I didn't do it, but it's something possible. A heart on the eye, a star on top of us, rainbow with clouds, a lovely one, pirate hook. So this one you can see it's following our animation. So if we choose muscular, you can see it's perfectly aligned to the hand. Now, to turn our experience into an actual game, what we will add is a leaderboard for the people who uploaded the most pictures. For now, it's not available in the React 3 VIVERSE library, but it's a feature available in VIVERSE SDK. So it's just we have to call the functions ourselves, but the client is available through the hooks. So first, we need inside our project to enable the leaderboard. Inside a VIVERSE Studio, go to SDK settings, leaderboards, and add a new leaderboard. Let's name it photos taken. The display name will be photos taken. Of course, it's for the leaderboard here. You can name it the way you want in your UI later. Display type, it will be numeric. Sort type descending. We want the one who uploaded the most pictures on top of the leaderboard and the most recent one. Okay, let's add our leaderboard. It's now attached to our world. You can add many if you want to. And now using the game dashboard client, we need to set up our game dashboard. Let's add those functions inside our use world. We need to have game dashboard and to call a function setup game dashboard that we will call once we have the user logged in because we need access to its auth token. Then if we are in dev, we don't do it. We create our game dashboard passing our auth token. Then we can set it to our store to have access to it anytime. And now we can call load leaderboard. Before declaring load leaderboard, what we need is inside our UI component, once the user is logged in, to get access to the user token, auth state is equal to use VIVERSE auth. So when it's changed, if it is set and we have an access token, then we can call setup game dashboard. It will be called at the beginning of our experience for users logged in. Now we can declare our load leaderboard function. Load leaderboard. It will be asynchronous. We only do it if it is initialized correctly beforehand. And then we set our leaderboard config. We only want 100%. We want the leaderboard that we named previously photos taken. And once we have all of that, we can call getLeaderboard. Once we have it, we set it inside our store, allowing us to display it nicely on our experience. But so far we have nothing in our leaderboard, so we need a function to save to leaderboard. What we need to do is every time one person takes a photo, we increment its value by 1. The SDK will take care of checking which user it is, what is its current score, and increment it. Then we can call upload leaderboard score and then load it again so we have the up-to-date value. Now, still in our store to have our code organized properly, when we take a picture and send it to Pocketbase, and then we can call save to leaderboard. To be able to try it, as it's a feature you need to be authenticated, we need to build and to publish our app to update it. Let's do it. Let's reload it. We have made a lot of progress since before. Okay, let's filter on leaderboard. We can see ranking is empty. Let's go to an empty slot, enter photo mode. Let's zoom in a bit, take a picture, take screenshots, exit photo mode. We can see here it is, upload leaderboard record successfully. We now have access to the leaderboard to help you build the UI for it. What I do is in sample data, I created fake names with the same format that we found in the leaderboard. So in development, we have access to it. You can fine-tune the UI, so it's ready for production once you have actual data in your real game. I will skip the UI part because it's not very interesting, but you can see what I have done. I'm using Tailwind, I'm using micro animation and keyboard shortcuts to allow you to have a nice user experience. Same, if you go to it, I play a small sound. You can find all of this in the final code. But the goal is to transform it from a draft to a true experience. If I press E, you have here the borders to show only the part that will be sent as a picture. I made the UI for the pose picker, same for the items. And I also added a background picker. It's very simple, but it's a nice addition to the project. Again, a shortcut if you want to exit it, E to open it, and if you press E, it will take the picture, it will close automatically. The goal is really to make the experience as smooth and seamless as possible. Thank you for watching, I hope you enjoyed this video. Please hit the like button to help this channel be more visible to other creative developers. A huge thanks to VIVERSE for the opportunity. I'm impatient to see your projects on the platform. All the documentation links to get you started are in the description. Don't forget to subscribe to not miss my upcoming tutorials. If you want to continue your 3D web development journey, give a look to my course or watch one of my other videos like this one, available here.